A Riemann sum is used to approximate the area underneath a curve. So for example, if we just had a straight line going from 0 to 10, we're able to easily find this area underneath the curve just by multiplying the height by 10. But if we have an exponential function going from 0 to 10, we're not able to calculate this area. So what we need to do is use a Riemann sum to find an approximation of that area. A Riemann sum uses shapes underneath the curve to approximate the area underneath the curve. So for instance, in this shape, we have 4 rectangles, and we're able to find the area of these rectangles, and that gives us an approximation of what the entire area underneath the curve is. So if we were to calculate what this rectangle plus this rectangle plus this rectangle plus this rectangle equals, that will give us an approximation of what the entire thing underneath the curve is. But it's still an approximation because there's areas that aren't accounted for. There are 4 main types of Riemann sums. There's a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, and a trapezoidal Riemann sum. All of these are approximations of what the actual area underneath the curve is. These two, the left and the right Riemann sum, are the most inaccurate, and while the midpoint and trapezoidal are the most accurate, but they also take the most time. And then these two, your n stands for the amount of subgroups you have, and then this stands for your interval you're finding the area underneath is. So for this, we're going 4 to 10. So this is asking you to find the area underneath the curve between 4 and 10. So you're ignoring this area, 0 through 4. If it asked you instead to find the area 2 to 8, you would find the area 2 to 8. This bottom number is your first number, top number is your number you're going to. The first step in any Riemann sum is to divide your interval into subgroups. So our interval is the full graph, 0 to 10. We know this because 0 is the number we're starting with, and we're going to 10. If this number were 2 to 10, we would start from 2 and go to 10. If it were 3 to 7, we would start here and go all the way to 7. But since it's 0 to 10, we're going from the beginning of the graph all the way to the end. And then this n stands for the amount of subgroups we have. So in this case, we need 5 different subgroups. So we're dividing 0 to 10 into 5 different subgroups. And in order to do that, we're going to have each subgroup have a width of 2. So 8 to 10 is going to be a subgroup, 6 to 8 is going to be a subgroup, 4 to 6, 2 to 4, and then 0 to 2. Our second step is to make shapes out of each subgroup. So let's look at our last subgroup, 8 to 10. We are going to make a rectangle from this subgroup. And since it's a left Riemann sum, what we're going to do is we're going to go to the left of this subgroup, which is 8, and then come up until it hits the slope, and then come over and make a rectangle. And then we're going to do the same thing for all of our other subgroups. So 6 to 8, start at 6, come up, over, 4 to 6, up, over, and then 2 to 4, we're going to go up and then over. And then 0 to 2, at 0, there's not a height, so we're not going to come up at all and just come straight over. And then our last step is to calculate the area of each of these rectangles. And to do that, all we need is the height of here, which we're going to get from this formula, and then we're going to multiply by the width down here. And then we're going to add each of these up until we get our total area. So at 8, when x equals 8, y is going to equal 64. When x equals 6, y will equal 36. When x is 4, y will equal 16. When x is 2, y will equal 4. And then when x equals 0, it's going to equal 0. And then we now have the height, and we know the width is 2 because of this. And we're just going to multiply them together to find the area of this rectangle. So we'll have 128, 72, 32, 8, and then this 0 times 2 is just going to be 0. And then we'll add these up to get 40. That's 40 plus 72 plus 128. And then all together, that's going to be 240. So that is our approximation for a left Riemann sum. And keep in mind, this is an approximation because we're not accounting for this area underneath the curve. So all of this in green is unaccounted for. That means there's more area that we're not accounting for. So this 240 is an under approximation because there's more area that we didn't account for. Important thing to remember with Riemann sum is the greater the value of n, which is the amount of subgroups we have, the more accurate the approximation is. So if n equals 10, that's going to give us a much more accurate answer than when n equals 5. So if n were 10, we would divide 0 through 10 to 10 different subgroups, so each subgroup would just have 1, and we would come up and do the same thing we did before, but we would just have a lot more rectangles to account for. And when n equals 10, we get a approximated area of 285, which is a different number than we got when n equaled 5, which was 240. And this 285 is much more accurate than the 240 because our amount of subgroups we have is a lot bigger. And there still is unaccounted for area when n equals 10, so this is not an exact answer, but it's more accurate than this number was. Next, we're going to do a right Riemann sum. And a right Riemann sum follows the exact same steps as a left Riemann sum, except for the second step, which is only slightly different than before. So we're still going to divide it into subgroups and calculate the area, but the shapes we make are just going to be a little different. So looking at our interval, we're working with 2 to 10. So it's similar to before, but we're going to ignore this first quadrant. So we're only looking at the area underneath the curve from 2 all the way to 10. And then we're going to divide it into 4 equal subgroups. So 2 to 10, to get equal subgroups, we need each subgroup to have a width of 2. So 2 to 4 is going to be subgroup, 4 to 6, 6 to 8, and then 8 to 10. And here's the difference with a right Riemann sum. Instead of going to the left and coming up, we're going to go to the right and come up. So for our subgroup 8 to 10, we used to go to the left, start at 8, come up, and then go over and down. But instead, we're going to go to the right and go to 10 and then come up until we hit the graph and then come over and then down. And then same thing through 6 to 8, we're going to start on the right of it, come up, over, down, up, over, down, up, over, down. And as you notice with this, we have excess on the outside of the slope. Before it was inside, but now there's a chunk right here that's being over accounted for. And that's going to make this a over approximation of what it is. And just keep in mind, a right Riemann sum isn't always an over approximation. Sometimes it might be an under approximation depending what the graph looks like. But for this case, since we have a sizable chunk outside of the slope, it's going to be an over approximation. And then after that, it's going to be the same process with finding the area as it was before. We just find the height and then find the entire area of this rectangle and then add all the areas up together. So at 10, the height will be 100. At 8, the height will be 64. At 6, the height will be 36. At 4, it will be 16. And then height of 100, width of 2, it will be 200. Then 128, 72, and 32. And then we just add these all together to get our approximation for a right Riemann sum. So for a right Riemann sum, we get an approximated area of 432. Our third type of Riemann sum is a midpoint Riemann sum. And for this, step 1 and 3 stay the same, and step 2 changes. So for this problem, we're going to work with the interval 2 to 8. So we're going to ignore anything before 2 and anything after 8. So we're only working with 2 to 8. And then we only have 2 subgroups that we need for this problem. So to divide our interval 2 to 8 into 2 different subgroups, we're going to need a width of 3. And to find that, you look at your interval 8 to 2, subtract them together equals 6, and then we need 2 subgroups, so divide it by 2 equals 3. So then our width equals 3. So our subgroups are going to be 2 to 5, and then 5 to 8. And then for a midpoint Riemann sum, for our shapes, we're going to do a similar thing to what we did before with the left and right, but instead of going from the left and coming up, or starting from the right and coming up, we're going to start at the middle of the two. So 5 and 8 in between those two is 6.5. So we start at 6.5, come up until we meet the graph, and then that's going to be our height. And then same thing for 2 to 5. The middle of that is 3.5. And so that's where we come up, meet the graph, and then come over. And then step 3 is the exact same. We just find the area of our rectangles and then add them together. So the height right here would be 12.25, and then the height for at 6.5 is going to be 42.25. And then we would just need to multiply that with the width, which is 3. So in total, this rectangle is equal to 126.75, and then this rectangle is equal to 36.75. If we add those two together, we get 163.5. So for a midpoint Riemann sum across the interval of 2 to 8, we get an approximation of 163.5. And a midpoint Riemann sum is more accurate than a left or a right Riemann sum, because if you look, this chunk right here gets canceled out by this, or close to canceled out. There's still some room where it's an approximation, but it's more accurate than the left or the right. Same thing for here. This right here would cause an overestimate. This chunk right here would cause an underestimate. But the sum of this cancels out this, so it causes a more accurate result. Our final type of Riemann sum is a trapezoidal Riemann sum. For this, we're going to work across the entire interval of 0 to 10, and then we need 5 different subgroups. So each subgroup is going to have a width of 2. So let's look at our last subgroup, 8 to 10. For a trapezoidal Riemann sum, you go to the left and then come up until you hit the graph. But you're not going to come over and form your rectangle. Instead, you're going to come to the right of the graph where the 10 is, and then come up again until you hit the slope of the graph. And then you're going to connect the 2 points together. And then you're going to do the same for every other subgroup. A trapezoidal Riemann sum is a very accurate way to approximate the area underneath the curve, because as you can see with this, there's very little room where there might be an overestimate or an underestimate. With a right Riemann sum, there would be an entire area that would be causing us an under approximation or an over approximation. But a trapezoidal one follows the slope roughly, so there's less of a room for error as there would be for a left or a right Riemann sum. And then after you get this, all you need to do is the third step and just calculate the area. So for this, it does take more time than the other ones, but it's a more accurate way of finding the area underneath the curve. So for this, I would just separate it into triangles and then rectangles, and then find the area separately. So for this, we have a height of 100 when x equals 10, and then when x equals 8, we have a height of 64, and then a height of 36 when x equals 6, when x equals 4, 16, when x equals 2 is 4, and then 0. And then we're just going to calculate the triangles and the rectangles with this information. And after calculating the area of all these rectangles and triangles, you get an approximation of 370 for a trapezoidal Riemann sum. Some other things you need to keep in mind is that sometimes the data can be shown in a table instead of a graph. So whenever this happens, you can either just translate the data you're given onto the graph and then solve from there, or you can picture it like each one of these is your subgroups. So then 0 to 1 is a subgroup, 1 to 2 is a subgroup, 2 to 3, and then 3 to 4. And then for something like a left Riemann sum, you would look at the left of this. So it'd be left of this would be 0, left of 1 to 2 would be 1, left of 2 to 3 would be 4. Same thing goes for a right Riemann sum, trapezoidal, or a midpoint. So you just need to visualize it, or if that's too hard, just make a graph, and it makes it a lot easier. And then second thing you need to memorize is just that when n stands for subgroups, the amount of subgroups, the more subgroups you have, the more accurate it is. So if we only have 2 subgroups, this isn't going to be very accurate, because look at all this extra space over. Now if we had something like 1,000 subgroups, there would be so many rectangles that there'd be very little excess. And as n approaches infinity, or the amount of subgroups you have approaches infinity, then the approximation is just going to get more and more accurate until it's exact. The final thing you need to do is know how to tell if it's an overestimate or an underestimate of the actual area underneath the curve. So for this, let's divide it into 3 subgroups into a left Riemann sum. So for this will be an underestimate because of all of this area that we're not accounting for that's behind the curve. Because we're only calculating this area and this area, but there's still area that we're not counting that's underneath the curve. So this would give us an underestimate. But if we were to do a right Riemann sum, we would get an overestimate because of the area above the curve that we are accounting for that doesn't actually exist. So all of this area right here, we're adding on to our total value, but it's not actually underneath the curve. Because with Riemann sums, we're trying to find the value underneath the curve, but this area here isn't underneath the curve, and we're counting it. So in this case, a right Riemann sum is an overestimate. And a right Riemann sum isn't always going to be an overestimate, and a left Riemann sum isn't always going to be an underestimate. Because if the graph was negative, and let's say we did a right Riemann sum, it's actually going to be an underestimate this time because of this area here that we're not accounting for. And if we did a left Riemann sum, it would be an overestimate. The trick is just to find whether there's excess underneath the curve or if there's excess above the curve. And that'll give you whether it's an overestimate or an underestimate. For a midpoint Riemann sum, if it's concave up, like this graph is, a midpoint Riemann sum will be an underestimate of the actual value underneath the curve. And then the opposite true is true for a trapezoidal Riemann sum. So for concave up, a trapezoidal Riemann sum will be an overestimate. And then if this was a concave down, the trapezoidal will be an underestimate, and the midpoint will be a overestimate. Here are all your rules for overestimates and underestimates, depending what the graph looks like and what type of Riemann sum it is. So if the graph is positive, or really if the graph is increasing, the right Riemann sum will be an overestimate, the left Riemann sum will be an underestimate. And then the opposite is true if the graph is decreasing. The right will be an underestimate, the left will be an overestimate. And then for our midpoint and trapezoidal Riemann sums, if it's concave up, so if it looks like this, or even just a section of this, the midpoint will be an underestimate, the trapezoid will be an overestimate. If it's concave down, the midpoint is going to look like be an overestimate, and the trapezoid will be an underestimate. Here's your final problem of the video. Solve for a left, right, midpoint, and trapezoidal Riemann sum across this interval with 4 different subgroups, and then include if it's an over or underestimate. And then just be warned, this is a different exponent than before. And then do it on your own, and then I'll show you the answers in a second. Here are the answers. For a left Riemann sum, you should get 1,600, and it's an underestimate. For a right Riemann sum, you should get 3,584, and it's an overestimate. For a midpoint Riemann sum, you should get 2,592, and it's an overestimate. For a trapezoidal, you should get 2,448, and it's an underestimate. And that's everything you need to know about Riemann sums. If you missed any of these, in the description, there's videos with doing these exact problems about 2 to 3 minutes long, and it'll show you anything you messed up.